Our next speaker is Alan King with the iRODS Consortium, and he's going to be talking about the iRODS development environment and testing environments, version 8.
Thanks, Corey. So I'm Alan. I'm one of the developers on the iRODS team. And just like Corey said, going to talk about the development and testing environments that we use in the consortium. So here's a quick overview of what I'm going to go over. The motivation behind these tools that we've built, a history of what we've tried before, limitations present in that history, the development environment, the testing environment, and then future directions. So the main reason that we put a lot of effort into the testing and development environments is because passing tests help us to build confidence in the changes that we make, and in so doing can give us confidence that the system is working. I imagine that's very important for a lot of you, and we would like to be able we would like for everybody to be able to run these tests that we use to build our own confidence in order to build confidence in the system. So quick 10 years here of history as we've tried to develop a testing infrastructure for iRODS. I'm not going to read through all of these, but we will kind of zoom in on the most recent iteration as it, as I said, presented a number of opportunities and challenges. So in the most recent iteration, we put Jenkins into Docker, which runs Python scripts to launch other Docker containers to run our build and test hooks. So that just means that the tests are being run in Docker containers via Python scripts from Jenkins, okay? The reason this was kind of limiting is because everything was tied to Jenkins. We each had to maintain our own instances. The pipelines that we developed were relatively inflexible and were kind of difficult to maintain. And there were a few other issues, but the bottom line is that our needs were not really being met as developers and project maintainers. This is all we really want out of a build and test workflow. You want to take your source code, put it in a box and shake it around, and then pop out some packages at the end, right? Then you want to take the packages, install them, shake it around to run some tests, and get a yes or a no, right? Did they pass or did they fail? Well, that is precisely what we built. So the first box is what we call the iRODS development environment. The second box is the iRODS testing environment. So first, let's take a look at the development environment. So this is available on GitHub. I've placed a link in the slides for you to go look at that later. This is a set of what we call the builders, which can build the iRODS source code, plugins, and externals for all of our supported operating systems. And we even have some debugging tools in there to boot. The main advantages that this affords us are we are not required to clone or copy repositories around as we were in the past, where everything had to be pushed up to GitHub, pulled back down into the Docker instances that Jenkins was running. And yeah, this just allows for a lot faster iteration from the developer perspective, and is still useful as a means of releasing packages. And again, that last point there is going to be a theme here. Having a consistent process for our development and our release are very important because it helps us build confidence. So here's an example of running the development environment, one of the core builders. That is one of these Docker containers that builds iRODS packages by slurping in your source code and spitting out packages, right? It looks kind of scary, but all it is a bunch of volume mounts, right? And so you need to feed it your source code for iRODS. The I commands are also built as part of this process, but in the future, these may be separated out. and then a place for your packages to land on your host machine. I'm not really going to demonstrate this, but it really is just a Docker run command to build the packages for any of our platforms. Next, we're going to go through the testing environment, which takes in those packages that you build from the development environment or any packages and spits out some test results. Actually, it's a lot more than that. In addition to running tests and giving us test results, the testing environment also allows us to kind of stand up a bunch of long-running containers in a variety of different configurations using Docker Compose. These are basically, as I said, some Docker Compose projects which are launched through locally run Python scripts and then manipulated from the host machine inside of the container, if that makes sense. What this allows us to do is have precision controls over the tests that we're running in parallel. So the typical runtime for the core iRODS test suite is like 8 to 10 hours, depending on the speed of your machine and how many cores you got and all that. And we've been able to reliably reduce it down to about 3 hours. So it's a very big deal for us as we try to merge in changes and make sure that everything is still working afterwards. This is also a very convenient way to reproduce issues. You all are filing a lot of things on GitHub and it says, I saw this in 428 and I say, I don't have 428 lying around. So let me just stand up an instance over here and try the thing you did, right? And did I see it or not? A lot of the times I do. You guys are very smart. Just like the development environment, the testing environment provides a consistent process for bench testing and automated testing for releases. So the testing environment has a number of capabilities. I'm not really going to run through all of these, but the main point is that you're able to stand up some long-running iRODS zones in a topological fashion. So this can have a catalog provider and any number of catalog consumers, and they can be federated together. The last set there are different ways that we run tests. So we run them in topology federation against plugins for units and of course the core tests. Here's an example usage of running the core tests. I may be demoing this later, but not the core test, but that takes too long. But what's happening here is you're feeding it packages in the project directory here. So if we picked Ubuntu 20, for instance, on the, sorry, I got ahead of myself. This is pointed at the Docker Compose project that describes the operating system and database that you'd like to run the tests against. So in this case, this is Ubuntu 20 with Postgres 10.12. The directory structure is such that the automatically generated Docker Compose container names reflect the operating system that they're running on. So it's easier for you to pick out, okay, I just launched 4 different zones. What is it, right? Then you feed it the packages that you'd like to run. In this case, these are where I keep packages on my development machine in North Carolina. And then you can tell it how many you'd like to run at the same time, which are then dealt out round robin style to the executors. And that's where the parallelism comes in. There are a lot of other options. We can read the help text together if you like, but I don't think that's going to be very interesting. So we'll move along. Here's some sample output. I picked kind of a random selection here. So maybe the demo would be more informative, but the idea here is that for each of the executors, you at the end get a list of tests that passed, failed, or were skipped, and how long it took for each of them, right? And this has given us a lot of insight into how to optimize our tests, how fast or slow things are running, in addition to just giving us more confidence that everything is working as expected. So yeah, this is the list of tests from the full list that provider number 2 received from this previous run. And then if we look at the output for provider number 4, it has a different set of tests. I had to snip it for size, but the idea is that they run all the tests just across the number of executors that you specify. And at the end, you get a little smiley face if they pass, and otherwise you get a list of tests that failed so that you can rerun it. Because the testing environment also allows you to run specific tests by name in a space delimited list, which is very convenient for the development team. At the end here, we also have a directory where the log output went. The idea here is that you can go and examine any failed tests to figure out why they failed, look at the logs and see everything that's got spat out from all of these 4 zones that we're running. And that is also configurable with the options. It just makes a default temporary directory by default. Just as a reminder, this is what we want to do. And we think we did a pretty okay job this time with setting up this flow for bench testing. And it being almost entirely Docker commands and Python scripts, you could easily see how this could hook into some kind of CI system or something like that in the future. Which leads to the next talk, which leads to the next set of points, which is the future. We would really like to have some kind of web application that's built on top of this in order to not have to type all that stuff that you saw. This might be Jenkins again. It could be something else. It might be something we make up. We haven't really decided yet. And along with that would come, hopefully, some form of automation and CI. And with enough parallelism, we could potentially be running our tests against every change that is committed, which would be super. We already do that. Sorry, every pull request on GitHub could be distributed to our, what do we call that thing? The data center at Renzi. We would also like to build and test clients. This is something that Dan Moore has demonstrated in our previous generations of CI, so it might not be that hard to port it into this environment as well. We'd like to be able to reproduce an entire environment. Okay, so if you've ever run iZone report, you know that it's a really big file that describes a zone and all the servers and all the things configured on it and everything like that. If we can feed this into the testing environment and have it reproduce your zone as Docker containers, that would be really great for reproducing the issues you guys are seeing. That's dream stuff right now, but it would be a big deal for us. Finally, being able to abstract away from Docker specifically would be nice in case something happens to Docker. So, being able to run with Podman or even virtual machines would be great. And then, of course, orchestration for distributing the executors across different nodes would greatly increase the speed of our testing for much faster releases. Without further ado, this is the build and test monitor. This is a web application that one of our interns wrote over the spring, early summer. And it's kind of what we're looking for. We're still working on it, but it's definitely heading in the right direction. So as you can see, it's kind of just the script as a set of boxes that you can type stuff into or select from so that you don't have to do as much typing. And then you can see your results right there at the bottom when you're done. And then he also made a history page. So it allows you to look back at your test runs very easily, see if they passed or failed, view the logs, and even rerun past tests to, I don't know, you could do it for any number of reasons. Thanks, Rocky. And finally, a lot of the point of me giving this talk is because we really want you guys to start using this stuff and let us know how it goes, because getting the development process easy for everybody to use would be really great, I think. So thank you.
Thanks, Alan. Any questions about any of that? All right, can we get a mic up here?
May you go back to the slide where you were showing the future steps that you would
Sure.
like to see? Yes, this one. So GitLab runners achieve most of these things that are mentioned here. They can do it through GitLab. So you can, it has a web UI. And yeah, of course, you can build and test, and it does log the output. And you can view the output of all the history of all the previous runs. And you can do orchestration also, because you can define multiple runners and it would spread them over.
Yeah, that's good. Yeah, we had considered a number of different technologies as a front end. I think GitLab came up at some point, but you know, in the end, we were like, well, let's just try to build a little web page and get something up quick. But yes, we've definitely thought about that, and hearing it come from the community is that's more points for GitLab.
All right, thank you.
Thank you.
Any other questions?
Probably I'm not interested in the test of the delay server, for example. Could you give a few examples of the things that I would benefit from?
Oh, sure. So with the testing environment, if you ever wanted to just try something on iRODS without completely screwing up your development servers or however people deploy things, you could just stand up any released package of iRODS. So I kind of glossed over this, but in the testing environment, there is the ability to specify a packaged iRODS version. And so you can stand up a zone for any past release of iRODS within reason. So maybe 4.2 is probably the cutoff, 4.2.0. But if you ever wanted to try something out, something crazy, then and not completely break your computer, then you could stand that up pretty easily. It's just a Python call away. That's one of my favorite features anyway.
All right, John.
And so this is brilliant. I'm really excited to give it a try. I've done a quick scan through the documentation, and I'd suggest having at the BREEDME start, but this is how to spin up an initial Docker thing to play with, kind of a thing. And then because your documentation is focused on the developers view, and I think this is got a much wider use of that, which is what I think you've gone on to say. So I think starting with this is how I want to spin it up. The other thing that I'd really like to see is sample CI integration. So this is how you integrate it with GitLab or with GitHub. Those kinds of things. Sure. And I'm happy to work with anyone else that's going to be doing that to try and put that together, because we've got both of these, and it would be really useful to have that set up. As part of that, the documentation doesn't mention the kind of the size you'd need to, how many cores, how much memory, how much disk space does it need, that kind of a thing. So I think that would be really helpful, but it looks great. So.
Oh, thank you. Yeah, so we should probably do some kind of profiling on that at some point. Yeah, and yeah, absolutely. If you guys want to play around with getting it integrated with an existing system, we would love to steal that. I mean, use that as well.
Any others? All right. Thank you, Alan.